Ever wondered how hackers steal data or crash entire networks? What if you could identify and stop spoofing, DoS, and man-in-the-middle attacks before they cause damage? In this video, I'll break down the most common identity usurpation attacks, from spoofing to DDoS, and show you how to protect your network. Whether you're an IT professional or just managing a small business, these tips will help you safeguard your systems and keep your data secure. Ready to outsmart hackers? Let's dive in. Identity usurpation attacks. The various attacks that will follow are mainly based on identity usurpation. Let's start with the spoofing attack. For example, when a machine sends an IP packet, everyone expects the source IP address to be the sending machine's own IP address. And it's the same for the source MAC address in the Ethernet frame, which should be the sender's own MAC address. And it's the same thing for services such as DHCP or DNS. For example, if a PC sends a DHCP or DNS request, well, that same PC will expect to receive a response from a DHCP or DNS server, which would be legitimate and trusted. Because addresses and services tend to be implicitly trusted, that's why spoofing attacks focus on vulnerability. That is to say, they will replace the expected values with falsified values. In the example, the attacker sends a packet with a spoofed source IP address instead of their own address. When the target receives these packets, it sends the return traffic to the spoofed address rather than the attacker's actual address. If the spoofed address exists, then an unsuspecting host with that address will receive the packet. And if the address doesn't exist, then the packet will be forwarded and then drop further down the network. An attacker could also send spoofed MAC addresses in order to falsify the lookup tables used by Layer 2 switches, or even falsify ARP tables used by routers. This type of attack also poses a problem on DHCP servers, because if the DHCP requests contain spoofed MAC addresses, then it will fill the IP allocation table of the DHCP server, leaving no room for other clients for normal use. Now, let's move on to denial of service attacks, which are also very common. In the normal operation of a business application, clients open connections to corporate servers to exchange information. That is, users open a web browser to the company's site, which has the effect of opening a TCP connection with the company. And it is at this point that exchanges can take place, or that a transaction can be made. So, if all users behave well, corporate servers should never be overloaded. This means that many transactions can take place without any problems. Now, suppose a malicious user finds a way to open a connection to the company's server. The TCP connection begins when the malicious user sends a SYN packet to the server, except that here, the source IP address is replaced with a fake one. The server will then add the TCP connection to its client table and respond to the wrong address with a CCNA. Since the fake address didn't ask for anything, there won't be an AKK response to complete this TCP three-step handshake. This connection therefore remains incomplete in the server table until it expires and is deleted. During this time, the attacker can launch new fraudulent connections again until the server's connection table is full. This will block TCP connections from legitimate users who will no longer be able to initiate transactions for the company. When an attacker is able to exhaust system resources, well, all of these services become unavailable or crash. This is called a denial of service, DoS attack, because it denies service to users. This type of attack can go even further, involving many systems that didn't ask for anything. In this case, the attacker will install a computer somewhere on the internet, which will control a set of other systems, infecting them with a malicious code or software. Each machine will then silently become a bot, which will function normally and wait for orders from the master computer. And when the time comes to start an attack, the controller will send a command to each bot, telling them to launch a denial-of-service attack against a target. This is called a distributed denial of service. DDoS attack, because the attack is distributed across a large number of bots, which floods or attacks the same target. Now we'll look at another type of attack that consists of forcing the target to process spoofed traffic so that it forwards it to a legitimate client. Based on the image, in this type of attack, the server is not the intended target. The goal is to get the server to mirror this exchange to the spoofed address, which is the target. This is called a reflection attack. The server that mirrors traffic to the target is called a reflector. The attacker can also send the spoofed packets to several reflectors, which would cause the target to receive multiple copies of the traffic. The main purpose of this type of attack is to consume bandwidth. We now turn to the man-in-the-middle attack. This attack consists of listening to the data that passes from one machine to another, avoiding detection. That is to say, the attacker places himself quietly in the middle of the communication path and passes himself through an intermediary of the two targets. This type of attack exploits the ARP table, which each host maintains to communicate with other hosts from their own local networks. Normally, if one host needs to send data to another, it looks for the destination host in its ARP table. If an entry is found, the Ethernet frame can then be sent directly to the destination MACI address. Otherwise, the sender must broadcast an ARP request, which contains the IP address of the destination, and they will have to wait for the recipient to respond with their own MAC address. We will now detail the process of the attack on the image. In step 1, the client broadcasts an ARP query to find out which MAC address is being used by the host that carries the IP 192.168.10. In step 2, the ARP request is sent as a broadcast to all hosts in the domain. This allows the attacker to receive this ARP request and prepare to exploit the information he has learned. Then, the real client, which carries the IP 192.168.0.10, will respond with its own ARP response and its real MAC address. And that's where all the finesse of this attack lies. Because in step 3, the attacker will simply wait a brief moment before sending a spoofied ARP response, which contains his own MAC address. Therefore, the attacker's goal is to send the latest ARP response, with the goal that all other hosts update their ARP tables with the most recent information. This process therefore poisons the entry in the ARP tables of all systems that would have received the spoofed ARP response. And like that, any infected system will blindly forward traffic to the attacker's MACI address, which is pretending to be the destination. In this type of hack, as soon as an attacker places himself between two hosts, he can listen to all the communications between these two hosts, and it can even modify the data that passes through. Here is the summary of spoofing attacks. When working on different types of spoofing attacks, remember that the attacker's main goal is to conceal their identity and deceive other systems in a malicious way.